Hello, students. I will be going through our assignment 2 questions, which is about section 3.2. It's called compound interest and continuous interest. There are some formulas that is handy if you keep them ready before you start the assignment. The previous section was about simple interest, and we already know that the future value with the simple interest applied to it will be P times 1 plus R times T. But this section is going to focus on more compound interest and continuous compound interest. So the first formula we're going to focus is the future value A is equal to principal, the original money, plus 1 plus R divided by M to the power of MT. Here, A stands for the future value, P stands for the invested amount, the principal money, R is the decimal in annual interest rate, T is the time in terms of years, M is the number of years the interest is compounded. And then compound continuous interest is future value is equal to P times e to the power of R times T. Here E is the natural number in mass. And then the final formula is annual percentage yield or effective rate, which you can shorten it as APY, is equal to 1 plus R over M to the power of M minus 1. So this homework is a little bit longer than the others. There are a total of 25 questions. And then I'm just going to go over these questions and how to answer them. So the very first question on the homework is, use the compound interest formula to find the future value of A for the following values. So the principal amount is 3,000, I is as 0.09, and N is 35. So using these three numbers, we're going to find the future value. And then because the question said use the compound interest formula, here we're going to break down the formula we're going to use for the rest of the questions. We are going to understand that I is equal to R divided by M. R is the rate. M is number of compounding periods per year. So M will be 2 if the question says semi-annually. M will be 4 if the question says quarterly, okay? And I is rate per compounding period. So basically, we're going to just divide the rate by the how many times we are getting compound. That's going to be the I. And then N is total number of compounding periods. And the formula we will be using is A is equal to 1 plus I. Again, here I is R divided by N to the power of N, which is the total number of compounding periods. So in this example, N is given as 35, I is 0.09. So we don't have to find R over M because they just gave us the I value. So we're going to use this formula. So A is equal to principal money, which is 3,000 here, parentheses 1 plus I value. I value is given as 0.09 to the power of 35. Because this is a yearly, it doesn't say quarterly, semi-annually. So this is just 35. And then using a calculator, you can find the answer. Question 2. For question 2, it says, use the compound interest formula, which is the same formula we used with the previous question. This time, we're going to find the present value, P. So we have the future value, we have the I value, we have the N. So we're going to need the same formula, which is A is equal to P times 1 plus I to the power of N. And then when we plug in the given numbers, we're missing P. To find the P, we need to divide 30,000 by 1.11 to the power of 120. And using the calculator, calculator will give us that the answer is 11 cents. So if you have the 11 cents, and then somebody's offering you 11% interest compounded yearly for 120 years, it's going to be at $30,000. Third question is asking find the annual interest rate and compounding period. These two are given. You're going to find the interest rate per compounding period. So there are two pieces of information they are giving. The rate is 3.4% and it is compounded quarterly. So how are you going to find the I value? That's what they're asking. So the I is always the given rate divided by, in this question, quarterly means M is equal to 4. So if you divide 3.4% by 4, the answer will be 0.85%. Similar question from, there's a lot of questions like this on the homework that if it says semi-annually, N will be 2. If it says weekly, N will be 52. So you can just read the textbook regarding those conversion to find the answer. My example 4 is actually question 10 on the homework. So the question says, if you have $900 and you have the 13% interest rate, and I want you to find the future value after 10 years in 3 different cases. If it is compounded annually, if it is compounded quarterly, if it is compounded monthly. So we're going to focus on the first one first, annually. So the formula we will need is the future value is equal to P times 1 plus I to the power of N. And we're going to apply this formula for 10 years. So the principal amount is 900, parentheses 1 is always here for us, plus, because 13% annually is 13% divided by 1 is just 0.13 to the power of 10. So when you apply a compound interest annually, the money will be $3,055.11. And then it says, subtract the initial investment from the amount after 10 years to find the amount of interest. So this is not the money that you made over the 10 years period. Remember, 900 was your original money. So when you subtract 900, this is how much interest you earn. And then this is the total value after 10 years. When we look at the case B, when the interest is quarterly, how is this going to change? So quarterly means N value is equal to 4. So because it's 10 years period, you will be, your interest will be applied 40 times. So I is equal to R divided by M. So 0.13 divided by 4 is, this is how much, what the rate is per each quarter. Now we're gonna plug in the numbers to this formula. The original value was 900, parentheses 1 plus. Now we don't use the 13% anymore because we had to divide 13% to 4 compounding period. And then to the power of 40, this will be the future value for $900 in 10 years. Again, when you subtract the original money, you can find out how much interest you make. Third part of this question is monthly. So monthly means N value is equal to 12. So for 10 years period, your N value is 12 times 10, which is 120. Now we're going to divide our rate by monthly, which is 12. So if you divide 0.13 by 12, this is the decimal we're getting. This is the rate we're getting. So we're going to now plug in these numbers to the formula. 900 is the original money. 1 plus, this is the new rate after we divided the rate by 12 to the power of 12 times 10, which will be 120. So this will be the total amount of money in 10 years if you choose the monthly option. Again, this is the interest you earn when you subtract the 900 original money from the total money. If we focus on now question 5, and this is number 12 on the homework, very similar question actually for the previous one. This time the P value is 1,300. The interest rate is 9.45%, and this is annually for 6 years. So if you look at here, there's nothing to divide by. We just plug in the I value. I value becomes just the same thing as the rate. and then this will be the amount. And then if you subtract your original money from the final money, you see that you will be only making $122.85 in 6 years with this interest rate. Now, this question asks you to create a chart, and then the chart is going from period 0 to period 6. So for period 0, you just put your original amount. For period 1, this is what period 1 stands for. So when n is 1, you just find this interest rate and then this amount. Now, if you look at what happens when n is 2, so same money, 1 plus 0.945 divided by 1 because it's still yearly, but this time n value is equal to 2. For period 2, you can find your interest rate and your amount, and you can fill out the rest of the table by changing the n value to these numbers on the calculator. Question 6. This is question 13 on the homework. It says, an investment company pays 10% compounded semi-annually. You want to have $26,000 in the future. How much do you want to deposit to have that amount in 5 years from now on? So if you understand what is given here, first of all, it's semi-annually and it's 5 years. So the n value will be 2 times 5, which is 10. And I is equal to R divided by M. So we're going to divide 10% by 2. That's going to make our I value to be 0.05. Now the future value A is equal to P times 1 plus I to the power of N. So A is $26,000. That's the future value. We don't know how much money we're going to put. So P is unknown. 1 plus I value is here 0.05 to the power of 10. And then using a calculator, you can either evaluate for P or you can solve the linear equation and you will find your P value. How much should you deposit now to have that amount in 10 years from now? So it's the same question, but it is 10 years, so semi-annually, 2 times 10 is n value will be 20. And then the I stays the same. If you now plug in these numbers to the equation, and you see that P value is 9,799.13. So it's not necessarily the half of the option A. So example 7. So as you see, many of these questions are very similar to each other. And then this is question 15 on the homework. And this time, we want to double our original amount. So we want to get our future value as 2 times what we put. So A is 2P, I is 0.23, and we're going to find the n value. So the formula is given. We're just going to replace the A with 2P is equal to P times 1 plus I value is equal to 0.23 to the power of n. If you just organize this equation and solve for n, because n is an exponent here, in order to solve for n, you need to take the log of each side. So log 2 is equal to n times log 1.223. Now, in order to leave the n alone, you need to do log 2 divided by log 1.23, and that makes the n value to be 4. You can also use some kind of equation solver websites to solve the equations when you're not so sure how to handle the logarithms. Example 8. For example 8, this is the question 16 on the homework. So question says, how long is it going to take you to double your investments, double your money with the following rates? First option is 6% compounded monthly. So doubling your money means that A will be equal to 2P. On option A, rate is 6%, so it's 0.06. Monthly means n value is 12. So the I value will be 0.06 divided by 12, which will be 0.005. Now, if we now plug in these numbers to the formula, 2P is equal to P times 1 plus I to the power of 12 times t. So where is this 12 times t is coming from? Because we will try to solve for time and it's monthly, so we will need to put here 12t. And then if you just cancel the p's, again, if you're not so good at with logarithms, you can just use the equation solver. And with this question, the time happened to be 11.58 years. For part B of the question, it's just a different rate, but the same problem. You can work it on your own. Example 9, this is question 17 on the homework. We want to use this time continuous compound. So when the question changes to continuous compound, your formula changes. So we're going to use the continuous compound interest formula to find the indicated value. P value is 4,000, rate is 4.35%, time is 5 years, and we want to find the future value. So the formula we're going to need is this time A is equal to P times e to the power of RT. Here, E is the natural number, so you're just going to plug in E to the calculator. E knows the value of the number E. The calculator knows its value. So with these given numbers, if we just plug in the numbers, 4,000 is the principal amount. E stays as a special number. Rate is 0.0435 as a decimal, and time is 5 years. And you can just find the amount you're going to accumulate in 5 years when you put this much money to the bank. Question 10. It's the same formula, continuous compound interest formula, but this time we're going to solve for P values. So A is given, P is missing, E is a special number. It's called natural number. Rate is right here, time is right here. So here you can either solve this equation on your own, or you can use some kind of calculator to solve this equation for you, and it'll give you the principal money you need to invest. Question 11 is the same formula, continuous compound formula, but this time they're asking us to find the t value. So A is given, P is given, E, you just type it E to the calculator. Rate, you have to express the rate in terms of decimal, and we just don't know what the t is. And again, because t is an exponent, you need to go through the logarithms to solve this problem. So time will be equal to 3.25 years. Question 12, which is the question 21 on the homework. So $5,000 is invested at 3% compounded continuously. So the key word is compounded continuously. It tells me that my formula is P times e to the power of R to the power of T, which is the first one. And we're going to plug in the numbers into the correct spot. So 5,000 is the principal P value. R is 3%, which is 0.03, and time is 7 years. I believe this homework, this question comes in 2 parts. First, you need to identify the values and you need to identify which formula to use. Then you have to actually use a calculator and find the amount after 7 years. Question 13 is a 2-part problem. If an investment earns 5% compounded continuously, how much should you deposit now to have $14,000 24 months from now or 7 years from now? So we have 2 parts of the question again. So for part A, we have the future value given. Rate is given as 0.05. And then 24 months is 2 years. And then when we plug in these numbers to solve for the principal amount, the principal amount will be $12,667.72 with these given numbers. But if you want to accumulate the same amount of money in 7 years, we can just change the numbers here, and then we will find out that we need to only input $9,865.63 to the bank if we want $14,000 in 7 years with this rate. I will be talking about now question 24 on the homework. It is a time question. How many years does it take for an initial investment of $20,000 to grow to $50,000? Rate is 9% and compounded continuously. As soon as I see this keyword compounded continuously, I know that this is the formula I need to use. $50,000 is the A value, $20,000 is the P value, E is a spatial number, rate is 9%, is as a decimal 0.09, and we just need to solve for T. Again, because T is as an exponent, you have to go through the logarithms, or you can just use some equation solver apps. It'll take about 10.18 years for this investment to grow to $50,000. So this is the last question we need to go over on this homework, which is your last problem on the homework. How long is it going to take to double your money if you choose 10% compounded continuously, or part B is 12% compounded continuously? So doubling the money means your final amount will be 2 times your P value. So 2 times P, 2P is your A value, P is your original number, E is the spatial number. On option A, 10% is point T, and we want to just solve for T here, solve for time. And then again, you have to go through the logarithms to solve for time. And it tells you that you're going to need 6.9 years to make your money double if the interest rate is 10%. And similarly, you can solve the part B of this question. You just need to change the rate from 10% to 12%. Thank you. Bye-bye.